Welcome to graphing sine and cosine with phase shifts and vertical shifts, part 2. All right, so this is going to complete the lessons on graphing sine and cosine, with the exception of a little review at the end, and that's going to be in the next 2 Nearpods. So let's learn how to graph with some vertical translations, and this first graph has a vertical translation. Our first step is to identify amplitude, period, phase shift, and vertical shift. So the amplitude is the coefficient in front of sine or cosine. It is always positive, so we see there's a negative there. So if we take the absolute value of -2, that would be 2. But the negative indicates that there is a reflection. The period, to calculate out the period, we would take 2 pi and divide by b. b is the coefficient on x, so b is 3 there. So the period is 2 pi thirds. Phase shift is what's added to x in parentheses. There is no phase shift, right? Because nothing's added in parentheses. There's no parentheses. So if you don't see any parentheses, there's no phase shift. And then vertical shift. The vertical shift could be in front, or it could be in the front or at the end, but it's something added to sine or cosine. Notice that it's y equals 3 minus. That 3 there is added to cosine. So it could be in the back, and we could have y equals -2 cosine 3x plus 3. Either way, the vertical shift is up 3. Let's fill in the values on our table. So we have x. The period change will affect x. I didn't leave a column. Sometimes I do leave an extra column and we'll cross it off. But I didn't leave a column this time for the phase shift because there wasn't any. So that's all that happens to x is the period change. And then to y, we have an amplitude change and a reflection. I'll put amplitude reflect. And we have a vertical shift. I'll just put vertical. All right, the x values are the same every single time. 0, pi halves, pi, 3 pi halves, and 2 pi. This is cosine, so the y values are 1, 0, -1, 0, 1. Right? Our values from the unit circle is cosine. As the radius rotates from 0 to pi halves to pi to 3 pi halves to 2 pi, those are the cosine values. They correspond with the values of x on the unit circle at those 5 angles. All right, period. We have period change. So the period values, to find those, we need to take the period and divide by 4. If you have a fraction, you're not going to divide by 4. You're going to multiply by 1/4, which is the same thing, right? But is something that you can calculate out. So we're going to reduce there. We can reduce by 2. So this is going to be a 2 in the denominator. So in the numerator, we have pi. In the denominator, a 6. So that means so the important values, like the x-intercepts and maximums and minimums, occur 1/4 the way through the cycle. Right? Notice those are quad angles, 1/4 the way through a full circle. Right? The period change changes how long it takes, but it doesn't change the fact that the graph is going to reach those important points 1/4 the way through the cycle. So period starts at 0, and we're going to count by pi 6. So 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6. And let's go ahead and reduce the ones we can. 2 pi 6 is pi thirds. 3 pi 6 is pi halves. And 4 pi 6 is 2 pi thirds. Right? for the amplitude change and reflection, we're going to multiply by -2. So all those y values will be multiplied by -2. So that's going to be -2, 0, +2, 0, and -2. And then for the vertical shift, we'll just add 3 to all the y values after the amplitude and reflection change. Right? So it's always a dilation before a translation. Right? So the amplitude change and reflection, that's a dilation, and then the translation is the vertical shift. So add 3, this would be 1, 3, 5, 3, and 1. All right, so we have all of our values. The period change is the new x. The vertical shift is the new y. Let's put a scale on this graph. We have values that are going up by 6. So let's make every line pi 6. That means every other line would be pi thirds. So pi thirds, 2 pi thirds, and this would be negative pi thirds. And then this could be this could go up by 1. -1, 1, 2, 3, 4, 5, and then we'll graph the points. So our first point is 0. Oh, and before we do that, let's graph the midline. Right? So we have a midline change. The midline is the same as the vertical shift. So now the midline, where the graph is oscillating about, is now at y equals 3. All right, so we'll graph our points. We have 0, 3. Wait a second. We have an addition error there. Was I looking at the 0? -2 plus 3 is 1. So I'm looking at 0, 3. That is not in the right spot because this graph has been reflected. All right, it's not sine. Sine starts on the midline. Cosine starts at a maximum or a minimum if it's reflected. So 0, 1. I don't have any explanation of why there was a 3 in there. Pi 6, 3, around the midline there, and then pi thirds 5, the maximum, pi halves 3, right? So 3 lines over, and we're back to the midline, and then the minimum is at 2 pi thirds 1. So here is the graph, and then it would just go back and do the same thing over again. The domain is -infinity to infinity. And the range would be -1 times the amplitude. So -1 times 2, and then plus the vertical shift. So plus 3. That will be the low value. And then +1 times 2 plus 3 would be the high value. So that would be, so -2 plus 3 is 1, and 2 plus 3 is 5. So there is the range. All right, so the graph is oscillating between 1 and 5. And on the next page, I have the steps shown, and most of them are already in your notes, how to calculate range for sine and cosine. So if you need to, pause the video so you can write the notes down in your book. Otherwise, join me on the next problem. And so I won't pause for you to write things down because you can just hit the pause button and pause me. All right, let's look at the helpful hints that I have over here on this page. There we go. So the top part is in your notes. The bottom part, the example, is not. Go ahead and add the bottom part. So for finding range, the low value is -1 times the amplitude plus the vertical shift. and the high value is 1 times the amplitude plus the vertical shift. All right, so here's our example, and that's the part I want you to put in your notes. And you can just put it in there. There's like some white space right next to that. So y equals 4 sine of 3x plus pi minus 2. The amplitude is 4. The vertical shift is negative 2. So the low value would be negative 1 times 4 plus negative 2. So that'd be negative 4 plus negative 2, which is negative 6. And the high value would be 1 times 4 plus negative 2. So that'd be 4 minus 2, or 2. So the domain is negative infinity to infinity. The range, negative 6 to 2. Right? And so that's how you calculate out the range. You don't even need a graph. Right? We don't even have a graph here, but we could calculate out the range. So go ahead and pause if you need to. And then we're going to go ahead and graph the next one. I think I have about 6 on here. And I would say 6, including the one we've already done. Let's see if I'm right. Any day now. Oh no, spinning ball of death. There we go. All right. So now we're going to graph y equals negative 2 plus 3 cosine 2x. Oh, you can ignore that. I ignored it in class when I did it earlier. So we're just going to do 1 period rather than 2 periods. All right. I don't even know if I have enough space for 2. All right. So the amplitude is the coefficient on cosine. That's 3. The period, although, you know what? If I have space, I'll do this. And I'll show you how to do it. We don't have to calculate any other points for it. If I don't have space, I won't. The period is 2 pi divided by b. b is 2. Oh, actually, maybe I'll have space for 2 periods. Let's see. So we're going to take 2 pi divided by 2, which is pi. There is no phase shift. And the vertical shift is down 2. And we have a minus 2 there. So we have x, we have period change, y, the amplitude change, and the vertical shift. So the x values are 0, pi halves, pi, 3 pi halves, and 2 pi. This is cosine again, so again it's going to be, sorry, the next one's sine. I started to write the 0 for the next one. 1, 0, negative 1, 0, 1. For the period, we're going to take the period and divide by 4. So pi divided by 4 is pi fourths. So we're going to count, we're going to start at 0 and we're going to count by pi fourths. Right? So count by pi fourths. So 0, 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, and the 2 pi fourths is pi halves. The 4 pi fourths is just pi. So notice pi, that's the length of the period, and all those important points occur 1/4 the way. This pi fourths doesn't look very nice. All right, for the change in amplitude, we're going to multiply by, what was it, 3. So that'll be 3, 0, negative 3, 0, 3. And then for the vertical shift, we're going to subtract 3. Subtract 2. So 3 minus 2 is 1. 0 minus 2 is negative 2. Negative 3 minus 2 is negative 5. 0 minus 2 is negative 2. 3 minus 2 is 1. And there we go. There's our values. All right. So if you note, I don't know if you noticed on this graph and the previous graph and this one, the Oh, the only ones in blue are the x and the y. That's our base graph. The red is all the transformation. So there was one horizontal transformation. We shrunk our graph horizontally. It's dilated horizontally. And then there are two vertical transformations. The graph has been stretched by a factor of 3, and we've shifted the graph down by 2. So this will be the new x. This is the new y. We need a scale on our graph. Let's make each one be a fourth. That works nicely. So this will be pi halves, and this will be pi, and that'll fit nicely. And there is no way we were doing 2 periods. Well, you know what? We could do a period the other direction. Yeah, let's do a period to the left. We'll do 2 periods. It's super easy. 1, and I'll go through it with you, and you're just going to follow along. -2, -3, -4, -5. All right, and let's first graph the midline. All right, so the graph is shifted down 2, so the midline is now at y equals -2. And then we'll go ahead and graph the points. So we have 0, 1. So that is right here. And then we have pi force -2. Oops. Oh, I put it at -1. It's like something is wrong. Something is wrong. Put it at -1, not 1. Pi fourths -2. Pi halves -5. 3 pi fourths back to -2, the midline. And then we have pi 1. So this is 1 period. If we wanted to graph a second period, we would just follow the points. All right, so notice that it's every time we move to the x, we move 1 to the across the x, the graph is either going to the maximum, the midline, or the minimum, and it's just going to go through the same process again. So if we go from left to right, from the graph we have there, or excuse me, from right to left, for the graph that's already graphed, we have max, midline, min, midline, max. So just do it again. So we already have the max. So midline, min, midline, max. There is another period. All right, so once you have 1 period graphed, you don't have to find the points because it keeps doing the same thing over again. So you just follow the pattern after that. All right. Oh, domain and range. Domain, -infinity to infinity. The range would be, and it'd be bracket because it actually goes to these values, -1 times 3 minus 2, and 1 times 3 minus 2. So I'll just put it over here. So that's going to be -3 minus 2 would be a -5. 3 minus 2 would be a 1. And that's the same thing we can see from the graph too. All right, 2 done. We're on to our third one. And I'm just going to check how long am I recording. Okay, I'm at 19 minutes. I might make 2 videos out of this. We'll see how long it takes me to get to the next one. All right, this one we had a sine and we have a phase shift. Matter of fact, we have all 6 things. We have x, or well, we're always going to have an x and y. That's the base graph. But we have all 4 transformations. We have a period change. There is a phase shift. There is an amplitude change. And a vertical shift. And they always go in this order. All right, you do the dilations on x and y first, and then any translations. The amplitude is 2, the coefficient in front of sine. The period, oops. I have a recording box, and I guess I'm too close to it, but it's not letting me write. It's still not letting me write. What the heck? Okay, now it decides to write. The period would be 2 pi divided by b. b is 4. It's the coefficient on x. So 2 pi divided by 4 is going to be pi halves. Right? And so that's the period is going to go through the whole cycle in pi halves. For the phase shift, we'll set the parentheses equal to 0 and solve. So we have 4x plus pi equals 0. Subtract pi, so 4x is negative pi. And then divide by 4x is negative pi fourths. So that is, we are shifting to the left. And then the vertical shift is down 1. So this graph is horizontally compressed because now it's going through the whole cycle. It's going through 4 times as fast. It's getting through in pi halves instead of 2 pi. It's been vertically stretched by a factor of 2. And then it's been shifted to the left and down. Oh, and it's down 1. Let's fill in the x and y. So 0, pi halves, pi. 3 pi halves, 2 pi. And now it's sine, so it's 0, 1, 0, negative 1, 0. All right, let's calculate all our transformations here. For the period values, you take the period, which is pi halves, and divide by 4. Dividing by 4 is the same as multiplying by a fourth, so this would be pi eighths. All right, so we're going to start at 0 and count by pi eighths. So pi eighths, 2 pi eighths, 3 pi eighths, 4 pi eighths. And then we can reduce the 2 pi eighths to pi fourths and the 4 pi eighths to pi halves. And notice that's the same as the period. Right? It has to be. If not, we have a mistake. So for the phase shift, we are going to subtract pi fourths. Now some of those fractions, and we subtract them from the period values. You subtract from whatever column has values next to the phase shift. All right, so if there's a period change, you add or subtract, depending on which way you're going, from the period. If there's no period change, just a phase shift, then you add or subtract from the old x values. But some of those values are in terms of 8 as a denominator. So let's right away rewrite pi fourths as 2 pi eighths. So if the denominator on the fraction that we're combining with has an 8 in the denominator, then we'll use 2 pi eighths. If it has a 4, then we'll use pi fourths because one of them has a 4. But no problem subtracting pi fourths from 0, it's negative pi fourths. So now we'll use 2 pi fourths, or 2 pi eighths. So pi eighths minus 2 pi eighths is negative pi eighths. This one's easy. Pi fourths minus pi fourths is 0. 3 pi eighths minus 2 pi eighths, we're going to use eighths now, would be pi eighths. And instead of the 4 pi eighths, because this is the end of the period, which is pi halves, why don't we just take that number there, the 2 pi fourths. That'll go nicely with our pi fourths. 2 pi fourths minus pi fourths is pi fourths. Now, if I had used the 4 pi eighths, I'd have 4 pi eighths minus 2 pi eighths is 2 pi eighths, and 2 pi eighths is pi fourths. So you get the same answer. All right, so that's our new x. For the y values, for the amplitude, we are going to multiply by 2. So this would be 0, 2, 0, negative 2, 0. And then we will subtract 1. So negative 1, 1, negative 1, negative 3, negative 1. And that's the new y. We'll go ahead and label the graph, because it just happens that these don't have values in there. Usually I try to pick one that works nicely with the particular graph. So we'll just label it to be nice with our particular graph. So we've got eighths in there. Let's make every line an eighth, which means every other line is a fourth. So pi fourths and 2 pi fourths, which is pi halves, and 3 pi fourths and pi. And then moving this direction, this would be negative pi fourths. And these are just be 1 and 2 and negative 1 and negative 2. And then we'll go ahead and graph our points. So we're going to graph negative pi fourths. Don't forget the midline. All right, we're shifted down 1. The midline is at y equals negative 1. So now we'll go ahead and graph. So we have negative pi fourths and negative 1. So sine starts on the midline. We have negative pi eighths 1, and then goes up to its max. And then we have 0, negative 1, back to the midline. And then pi eighths negative 3, down to its min. And then pi fourths negative 1, back to the midline. So here is the graph. And if we wanted to graph 2 periods, so this is 1 period. If we wanted to graph 2 periods of sine, we would just follow the pattern, right? So it went up, down, back to the beginning. So it would go up, so here up, because it goes up to the max. Next one over, it goes back to the midline. Then it goes down to the minimum, and then back to the midline. So that would be a second period. So this right here is 1 period. Right? And then you would just follow the pattern to get a second period. But we're focusing on just graphing 1 period. So I'm just going to do it on those 2. The domain, negative infinity to infinity. The range would be negative 1 times 2 minus 1, and negative 1 times 2, positive 1. I get into a rhythm there. I know what I mean. Positive 1 times 2 minus 1. So that would be negative 2 minus 1 is negative 3. 2 minus 1 is 1. And that matches our graph too. All right, another one done. Let's see where we are. We're at 28 minutes. I think I am going to pause here and do the last couple on the next video. So if you need to, pause, rewind if you need to look at anything else again. Otherwise, I'll see you on the next video. So bye for now.